You're listening to MedX, the Medical Extrusion Podcast, presented by US Extruders. Extrude with confidence, custom extrusion equipment designed for you and your application.
Hey folks, welcome back to the MedX Podcast. Today's guest is Brooke Gov, sales engineer at Rose Medical, an ISO 13485 custom medical device contract manufacturer located in Grand Rapids, Michigan. The focus of our discussion will be thermoforming capabilities, tipping and flaring, and also Rose Medical's investment into laser processing of metals and plastics. Enjoy. Hi, Brooke. Welcome to the MedX Podcast. It's great to have you on.
Thanks for having me.
Excellent. Hey, Brooke, I was looking at your website, Rose Medical, and you do a good job of providing the history and a timeline. And I noticed in 1998, when the company was founded, you were founded as a machine builder, equipment builder, I think mainly maybe tip forming equipment. And maybe 6 years later, you transitioned to a contract manufacturing organization, which I found interesting, starting from an equipment builder to a contract manufacturer. And I know you've added a lot of capabilities since then, CNC machining, injection molding, certainly thermoforming's your roots. And then, we're going to talk a little bit later about your foray into laser processing. But if you can kind of give us a high level snapshot of Rose Medical, what your capabilities are, that'd be great before we start.
Yeah, sure. So, yep, all that's correct. Rose was founded in 1998, mostly as a custom machine building company. So we focused mostly on manufacturing and QA equipment for a whole wide variety of different medical device contract manufacturers or OEMs, really the whole slew of the manufacturing side of things. And then, as you mentioned, in the mid-2000s, the decision was made to really no longer externally sell that equipment anymore, but instead pivot to internal contract manufacturing. And so while we don't sell any of that equipment externally anymore, we still maintain all of that expertise, and we have an entire manufacturing engineering team on site here whose primary focus is really designing and building custom equipment that we use in our current contract manufacturing. So as a result, if you walk back into our clean rooms, most of the tooling and equipment that you'll see back there is actually custom designed and built here internally by our team here at Rose. So that kind of opens up the breadth of capability quite a bit and gives us a wider range than some standard equipment would.
Yeah.
So in terms of capabilities, we really do it all in terms of the catheter and cannula space. So as you mentioned, our primary capability that we started with really was tip forming, and that still maintains to be one of our most prominent and most capable technology that we have here is our tip forming. But since we've continually looked to add a whole wide range of capabilities to the list to really be able to meet our customers' needs. So these include anything from flaring, hubbing, catheter lamination, braid reinforcement, coil reinforcement, balloon dipping, whole range of device assembly capabilities. And then in addition to the actual device assembly, we also do quite a bit of final packaging as well. So including anything from pouch sealing, tray sealing, label management, that kind of thing.
Okay. From tip to hub.
Exactly. Yep. And then one thing that really sets Rose apart from some other contract manufacturers is the fact that we process both thermoplastic and silicone devices. So we actually have one of our clean rooms dedicated solely to silicone processing. And in this room, we do a lot of silicone wire reinforcement, silicone molding, and silicone device assembly. And then, as you mentioned, earlier this year, we did open a secondary manufacturing facility, and that houses two of our most recent capability additions, being injection molding and laser processing. Wow. So it sounds like a lot, but really that's kind of the goal here. Is our goal is to be a one-stop shop contract manufacturer for our customers. We want them to be able to come in and say, here's a drawing of a complete device, make it for us, and that entire device is manufactured under our roof here.
Okay, excellent. Certainly important for OEMs to be able to contract out where you can have everything under one roof. So that's great. I know it takes a long time and a lot of effort, investment, and resources to do all that. So congratulations. since your roots are in the thermoforming, tipping and flaring, and you build your own tooling, and that's certainly one of your expertises, can you talk a little bit more about tip forming capabilities, some of the unique things that you do in that area?
Yeah, sure. So since our tipping equipment is custom, it gives us a much wider range of capability than some of your more standard off-the-shelf equipment might. And I would say one of the biggest advantages that our equipment gives us is the length range we're able to accomplish with our tip forming machines. So these tip lengths can be as short as, extremely blunt tapered tips, even rounded full nose, bull nose tips, or they can be up super long, tapered upwards of 3 inches long. So here you can see a really long, this is a PVC dilator extrusion that has a 3-inch long tip. So the big advantage here is you have a very rigid dilator extrusion, so you can really push against it, gives you really good pushability, but then this long tapered tip gives you the flexibility you need to follow along a guide wire in really tortuous anatomy.
Interesting.
And then I would say one of the other more unique tips that we do is actually a tip that has a spiral embedded into the tip. And this spiral gives you echogenicity in the dilator without having to add any secondary materials or additives to the device. And then what makes that unique about Rose is we actually form that spiral into the tip during the tip forming process rather than as a secondary material removal process. So it makes it much more streamlined device assembly, speeds up the throughput, decreases the cycle times, everything that you're looking for in a manufacturing setting.
Wow, very interesting. Very interesting. I know that you have also capabilities, know-how related to secondary operations with PTFE, which I find interesting. And let's talk a little bit about that, and just if you can kind of just generally talk about the capabilities, and then I want to talk later about kind of this type of application where you're forming a flare on the distal end and some other serves. But just kind of give us an overview of some of the things that you can do related to PTFE.
Yep. So as a lot of us know, PTFE is becoming a very prominent material in the industry due to a lot of its beneficial material properties. But on the flip side of that, it's also very difficult to process since it doesn't really perform like a normal standard thermoplastic would because of its high viscosity. But our team here at Rose has really invested a lot of resources into developing processes and equipment for secondarily forming PTFE. Honestly, pretty similar to the capabilities that we have in the standard thermoplastic realm. These PTFE forming capabilities include atraumatic tip forming, flaring, shape setting, similar to that part you just showed, and then also forging, which we can use as kind of an alternative to molding in the PTFE world. And then we also have discrete length etching capabilities, which aid in PTFE device assembly.
Okay, so you could selectively or dip or etch a portion of the PTFE component.
Yep, that's correct. So you can have a 6-inch long component that you need most of the OD to be PTFE for the properties, and then we can etch, say, 1 inch on the back end to be able to bond a hub or to reflow it onto another component, something like that.
Okay, interesting.
And that can be controlled to a very precise length rather than your standard reel-to-reel PTFE etching. Gotcha.
Okay. Yeah, you mentioned some of the challenges with PTFE from a thermoforming standpoint because of its viscosity, high temperature, and it's not a melt processable material, so it doesn't flow. So I know there's a lot of challenges when you're forming PTFE. I remember somebody told me that you kind of have to do it with brute force and then cool it as quickly as possible. So I don't expect you to share all that with you, but it's safe to say you've overcome a lot of those challenges.
Yeah, that's correct. So I would say, many years ago, our team kind of bought into the industry mentality of PTFE can't be formed. We just get what we get. But the word can't doesn't sit well in this building for more than about 30 seconds. Somebody's going to figure it out. So our team has really invested a lot of resources into developing some unique technologies there. And our president and founder, Todd, he isn't really involved much in the day-to-day operations of the business anymore. but instead he spends a good majority of his time in the lab researching, developing new technologies and processes that we use. And PTFE has really been one of his primary focuses over the last few years, just knowing that the industry, it's becoming extremely prominent. Somebody needs to be your go-to manufacturer when it comes to that, if we're able to get the beneficial properties out of it. And so he's really developed himself, as well as the rest of our engineering and technician team, have been very involved in developing both processes and unique equipment that we use to process the PTFE, which has really widened up our capability breadth of PTFE processing.
Sounds like Todd's having fun then.
Yeah, you don't see him in his office much.
Yeah, good. You know, there's a term, garbage in, garbage out. And the quality of a secondary operation, whether it be forming, tipping, flaring, overmolding, balloon forming, has to do a lot with the input tubing. If we're doing something, the tube. Can you talk a little bit about, you know, for the extrusion folks out there, share some of the key attributes, whether it's dimensions, tolerances, cut quality, particulates, gels, some of the key attributes that you have to, you need in order to have high quality, repeatable, with good process capabilities, PPKs for secondary operations?
Yeah, I would say two of the more important parameters when it comes to extrusions are probably your concentricity and then just your overall consistency in both profile and critical dimensions. Mm-hmm. So our machines are designed that we're able to adjust parameters to account for variability within the extrusions that we receive to an extent. So, you know, if your melt temp is slightly different, you got higher or lower stresses, whatever it may be, our machines can account for that. But if you have inconsistencies in an extrusion run of those things, that's causing our technicians to constantly be in addressing these issues. From a tipping processing standpoint, they're constantly having to come redial in, readjust, which, you know, it works for 500 parts, and then you go to run the next lot, and then stresses are different, and then your whole tipping process is up on its head. So I would say more than any one specific parameter or, you know, some of those more minor parameters, I would say the consistency across the board tends to be the most important parameter for us.
Okay. That makes sense. Yeah, that lot to lot variation can wreak havoc on secondary operations, right?
Yeah, definitely.
Okay. Excellent. Let's talk a little bit about a fairly new capability that you have, and big investment in equipment, technology, and resources to laser process metals and plastics. If you can talk a little bit about this new capability, the expansion in that area, and just some highlights there, that'd be great.
Yeah. So as I mentioned, the first of this year, actually, we opened up our secondary manufacturing facility, and it's just under a mile down the road from our primary manufacturing facility here in Grand Rapids. So that's a big advantage. We're sending people and items back and forth on a daily basis rather than having two separate facilities. So we're essentially acting as one company within two buildings. So not much is changing to the external, but it's just opening up a lot more manufacturing space and resources for us. And one of the main focuses of this secondary facility is our laser processing. And this facility has a state-of-the-art laser processing area in it that currently has 3 fiber laser welders as well as 1 fiber laser cutter, with plenty of room to grow and add as customer needs arise. Mm-hmm. So for the welding side of things, common materials that we're processing here: stainless steel, platinum, tantalum, titanium. A lot of these devices end up being pull wire assemblies, battery welding, IPGs, guide wires, that sort of thing. Mm-hmm. And the machines that we have do have 4-axis CNC motion control incorporated into them. So very precise welding location, as well as a decent amount of automation. So throughput on these machines is pretty high. And then on the laser cutting side of things, common materials here, again, stainless steel, nitinol, cobalt chrome, titanium, tantalum, etc. And then OD capabilities down to as small as like 10 to 15 thou on the OD, all the way up to 3/4 of an inch and more with some pretty unique tooling implementation there. So that's not just as easy as put it in and run, but we can go up 3/4 of an inch or more if needed. And then our cutter does have grip and regrip capability. So this opens up essentially unlimited length capability. A lot of these devices end up being flexible hypotube, shaft patterns, steerable catheters, that sort of things, or pull rings, stents, really anything.
Yeah.
And then you kind of mentioned the metals and plastics. So a lot of the welding and cutting is done more in the metal space. But then in terms of plastics, we also do have 3 UV laser markers that we run actually in our clean rooms, not in the laser processing room. And these laser markers are paired with vision systems. So it allows for very precise location control. So I got a device here that's got some depth marks in it.
Yeah.
And the UV laser marker is actually datumed off the tip here. And so the vision system will zero off the tip. And so these are held to a very precise tolerance in terms of the depth location. These marks can be anything from, depth marking similar to that part, logos, French sizes, etc. And we're really trying to steer a lot of our customers toward laser marking as an alternative to pad printing, since it's really just a much more robust process overall, faster cycle times, higher throughput, larger yield, but then also the robustness of the markings. They're never going to fade. They're never going to smudge. You can put them anywhere in the body and, the chemical nature is not going to impact the marks whatsoever.
Interesting. Back to the laser welding capability. Is that all with similar materials, meaning stainless steel to stainless, or are there any unique applications where you're welding dissimilar materials, like a stainless to a nitinol, for instance? I know that's maybe not a great example, but
yeah. Typically, it's in the similar to similar. You usually get the higher strengths when it's similar to similar, but we also have done some dissimilar materials. Nitinol is kind of its own game when it comes to laser welding, but you certainly can get some dissimilar welding compatibility. Okay.
Very interesting. You mentioned a lot about like laser cut hypotubes, pull rings. So there's sounds like a lot of the effort related to laser cutting of metals. Hypotubes is related to maybe steerable catheter shafts.
Yeah, that's correct. So we really brought on the laser to be a accessory capability to us, similar kind of to all the other vertical integration that we've done over the years. And laser, when you first look at it, looks to be more of a singular capability, but as a whole, Rose is really trying to implement this into the complete vertical integration. So pull wire assemblies that we could do the full catheter manufacturing to get your steerable catheter, or different things like that. So it certainly is a vertical integrating capability, but we're also doing a lot of just component cutting and welding as well.
Gotcha. Okay. Hey, Brooke, this has been a great conversation. I appreciate you coming on and talking about all the capabilities that are in, basically under one roof, so to speak, and the new introduction into the laser processing. Very interesting. Certainly that's an area of a lot of growth, and I think that probably next year this time you'll have a new building that you're opening up to put more machines in. Hopefully that'll be the case, but based on history, that probably will be the case.
Never say no, right?
Yeah. Excellent.
Yeah, thanks for having me. This has been great.
All right. Thanks so much.
Thank you for listening to MEDEX, the Medical Extrusion Podcast, presented by US Extruders. Please subscribe to make sure you're getting the latest episodes. For video episodes, go to us-extruders.com/podcasts. All links are available in the show notes.